This is the brief on the recursive Fibonacci series. So the source material we're looking at, it's all about tackling a popular coding challenge, how to generate the Fibonacci sequence using recursion. Recursion is just that technique where you solve a problem by having a function call itself with smaller inputs. And the Fibonacci series itself, where each number is just the sum of the two right before it, well, it's kind of the perfect example to see how this works. All right, let's dive into what makes this recursive approach tick. There are really three key things you need to get. First, you've got the core math rule. Super simple. The sequence always starts with 0, then 1, always. After that, every single number is just the sum of the previous two. So, 0, 1, 1, 2, 3, 5, 8, and it just keeps going like that. Second, and this is absolutely crucial, you need what we call base cases. Think of them like built-in stop signs for the recursion. So if the function's asked for the number at position 0, it just stops and gives back 0. If it's asked for position 1, it stops and returns 1. Without these, it would just run forever. They let the whole process wind down. Finally, you have the recursive step itself. But there's a catch. For any number n bigger than 1, the function calls itself for n-1 and n-2, then adds those results. Now, this looks elegant, right? But here's the warning. This recursive way can get really slow for larger numbers because it ends up doing the exact same calculations over and over again. A lot. Still, this approach is a fantastic, really foundational way to understand how recursive functions break down problems into their simplest